The risk of a certain event for a given location and time frame is the probability of the natural event occurring times its impact. If graphs scare you, let's take a step back. What is the area of a rectangle? Length times width. On the risk graph, our length is impact or consequences, which is along the x-axis, and our width is probability, which is along the y-axis. The bigger the area of the rectangle, the higher the risk. Take out a piece of paper and draw the x-axis and the y-axis. Label the x-axis impact or consequences with an arrow showing that it increases to the right. Label the y-axis probability with an arrow showing it increases upward. Now, think of a natural hazard event such as a magnitude 6 or higher earthquake in Los Angeles in the next 20 years. Think of the consequences: low, medium, or high. Make a mark on your x-axis. Now, think of the probability: low, medium, or high. Make a mark on your y-axis. Now graph your point, the fourth corner of your rectangle, if you will. What is the risk? Low, medium, or high? Now, think of a different natural hazard. Large flood in Nampa, Idaho in the next 100 years. Consequence? Probability? Low, medium, or high? Is the risk of a flood in Nampa higher or lower than the risk of an earthquake in Los Angeles? How does this relate to where limited national resources are spent to mitigate hazards? Remember that risk is probability times consequences. Never forget it, at least for a while. Linkages exist between natural hazards. Examples: tsunamis are linked to large displacements of water that may happen with earthquakes or large landslides into water. Some floods and coastal erosion are also linked to tsunamis. Can you think of some natural hazard links with a wildfire? You could have thought drought, lightning storm, soil erosion and landslides, flooding. Can you think of some natural hazard links with a volcanic eruption? How about a hurricane? Be creative, but make sure you can explain your creativity. Humans can turn hazards into disasters, into catastrophes, simply by being in the way. The more our population grows, the greater the probability that more people will be harmed by natural hazards. But we can also influence the magnitude and frequency of some natural hazards. Magnitude is the amount of energy released by a natural hazard, and frequency is how often it happens. Generally, the bigger the magnitude, the less often it happens. In other words, magnitude is inversely proportional to the frequency. Large earthquakes happen less often than small earthquakes. Small floods happen more often than large floods, etc. Well, remember the concept of environmental unity? Change causes change. We change our planet through farming, building cities, and industry. Some of this change actually increases the frequency of some natural hazards. One example: changes to our atmosphere caused by us is changing the amount of solar energy retained by the planet. This energy is driving the hydrologic cycle a little bit faster, so we are getting more severe storms. We will discuss more about this later. Consequences of hazards can be minimized or mitigated. A reactive mitigation response occurs directly after a natural disaster. An anticipatory mitigation strategy occurs prior to the natural disaster. Can you think of some reactive responses? Think of what first responders, emergency personnel, and the Red Cross do. Can you think of some anticipatory preparation? Which would you prefer? Reactive response includes dealing with direct effects such as death, injuries, homelessness, and property damages. Indirect effects includes dealing with emotional distress, donations of money and food, which is an economic loss, and taxes, another economic loss. Anticipatory responses include land use planning, insurance, evacuation, disaster preparedness, and artificial control of natural processes.